Welcome, I'm Fabian, and in the following I'm going to talk about how to map business requirements to the logical design. What we have done in the first step of the design was to create a conceptual design, where we have identified requirements, risks, assumptions, constraints. So what we need to do now is to map those information, all the information we captured during the assessment phase, during the conceptual design, and map them to our logical design, to create a logical design out of those requirements. So even though we don't get into that much of a detail like in the physical design, where we specify IP addresses, full qualified domain names, things like that, we still need to know which components we are using, probably how many components we are using, and since we need to know the limitations of those solutions, it is important to get a feeling, to know the components of our Horizon suite and build the proper solution for the business. So if we have a look at the Horizon logical reference architecture, we see that we have the underlying infrastructure layer like vSphere, like vSAN as a persistent storage for our virtual desktops or for our remote desktop session host that we then deliver as Horizon applications to the end user. For sure, we need some core infrastructure products like Active Directory, databases for certain management products, and need to have them in place. If we talk about the Horizon suite itself, we want our end user to connect to their applications. We want them to connect to the virtual desktop in our data center. And that's where we need the connection server. The connection server is a broker for the end user to its virtual desktop. Since the connection server must be part of the Active Directory domain, we cannot allow access over the connection server to the virtual desktop over an unsecure network. That's where we use the Unified Access Gateway, which is a virtual appliance, or a security server, which is still a Windows-based component that can still be used in our environment. So what else do we got? If we want to create or make use of the so-called linked clones, we require a view composer. We need to install the view composer. What else? Application delivery. When we talk about application delivery, we might want to create a solution where we have a lot of floating desktops, which are refreshed every time a user logs in, but still we want to be able to attach unique application sets to the certain desktop based on a user, on an Active Directory group membership. That's where we use app volumes, the so-called app stacks. What else can we deliver? Writable volumes. With writable volumes, we allow the user to install applications into the virtual desktop even though they have a floating desktop. Within app, we can deliver virtualized application. We can deliver virtualized application, for example, in Internet Explorer, to make sure we can still make use of legacy applications and let them run on a modern operating system. And last but not least, we want to store the user profile in a persistent and condition-based manner. We want to change the user environment based on certain conditions. And that's where we use the user environment manager. Those are only a few components that we design in the logical design phase, but we need to understand how they interact with each other. We need to understand what are their limitations for us to do the correct design decisions. When we talk about doing a logical design, it came up that best practice for a large-scale Horizon or virtual desktop infrastructure is to create a scalable design approach. And what we use here is the so-called Cloudpod Architecture. What does it mean? We differentiate between the management block and the resource block. Every resource block contains infrastructure components that can scale up to 2,000 connections. So if we have only 1,000 users, we can live with one management block and one resource block. If we need more than 2,000 connections, we just scale up and repeat the configuration settings of the first block to the second block. And that's how we can scale up within the Horizon environment to up to 5 resource blocks, which ends up to 10,000 connections. What do we have in the management block? The management block contains all components that are required to run the infrastructure. Components like the vCenter, like the connection servers, like App Volumes Manager, like Unified Access Gateways. All of those things are part of the management block. So in the end, if we combine the blocks of the management, the blocks of the resource components, we have a so-called pod, the point of delivery. And this point of delivery is our Horizon instance. Yeah? If we need more than 10,000 connections, we just create a second pod with the same architectural design decisions, the same architectural characteristics. And as we can see later, we are also able to integrate different pods with each other with the Cloudpod architecture. Since we need to map our requirements to logical design decisions, to logical design characteristics, we need to differentiate how do we classify our requirements. And that's where we have those design qualifiers. The typical design qualifiers are availability, manageability, performance, recoverability, security, and of course, costs. And it really depends on the business. How much weight do we put into each of those qualifiers? Yeah, there might be some businesses that are much more cost sensitive than others. Other environments might have a much higher focus on security. Others will require higher performance levels. So what we need to do is to weight those qualifiers and also to assign those qualifiers to the requirements that we have captured, that we have analyzed, that we have figured out in the conceptual design. So what information do we need to take care of when we talk about this design qualifiers? So first of all, if we talk about availability, we need to make sure already in the logical design that we don't have any kind of single point of failures, that we have a certain kind of redundancy. Yeah, measurement quantity numbers for the quality of availability are the class of nines, the redundancy levels, how many components can have an outage without having interrupt on the service. Those are really important things we need to figure out up front. Manageability, how easy is it to deploy, to manage, to maintain, to operate, to upgrade the environment? Those are things that can be very sensitive, because maybe we work in an organization that want to be ITIL conform, that has very specific characteristic or compliance reasons for certain management operations. Performance, what level of performance must the solution achieve? That is really a tough one. We can't really put that into real numbers, but we can say, okay, we need a certain amount of throughput for our bandwidth, since the users are using high performance protocols, high performance quality to 3D applications. We need to specify a certain amount of latency where we support this quality in our service. What else do we got? Recoverability. How easy is it to recover the whole environment in case of a data loss, in case of a disaster of our solution? Typical measurements we do here is the mean time between failures, the RTO, so the recovery time objective or the recovery point objective. When we talk about the security, we need to specify certain risks, we need to specify certain characteristics that we need to fulfill to be compliant to the company's security definition. Okay? So maybe we need to fulfill certain government regulation, maybe we need to fulfill some industry standards to be compliant in this area. So how does it look like? How do we map those qualifiers? How do we map in general requirements to the logical design? What we have gathered during the conceptual design is something like this. We know we have a table with requirements. We have a table where we describe those requirements. We need to add those requirements to a certain quality. Why do we do that? Because we might end up at a certain point where we have different requirements that have different goals, and each of those goals is one is probably assigned to the qualifier management, the other one is assigned to the qualifier of security, and then we need to make a decision what is more important for the business. We need to go back to the conceptual design and figure out, okay, we need to put our focus more on the manageability part or on the security part, and therefore change how we create the logical design. The next thing is, if we know, okay, the requirement is the solution must be centrally managed. One of the design decisions we do on the logical design is, we install the Horizon 7 connection server and use the integrated administration tools and provisioning capabilities to create new virtual desktops to assign users to those desktops. That's a logical design decision. We don't go into that much of a detail. We don't say, hey, we need exactly 6 connection servers, we need this IP addresses. We just say we use the Horizon 7 connection server capabilities to fulfill this requirement. If the user must be able to access the virtual desktop via the internet, we can make use of the Unified Access Gateway and allow a secure access over an unsecure network. For sure, this is a design decision we already have made, since we also have an alternative design decision in place. We could have chosen the Windows-based security server, but since the trend is going to using more the Unified Access Gateway for the secure access, we made the design decision on a logical level to use the UAG. The last requirement in our example is that the end-user access brokering mechanism must be high available. And that's why we install our connection server in a multiple fashion. So we install connection server replicas to be able to handle more connections and to be able to have a higher availability in case that one connection server fails. For sure, every design decision, even on the logical level, already have an implication on the design. We should track the implication as well, which means in this case we will need a load balancer to handle the load across multiple connection servers, to discover a failure of a connection server. That's a topic we will discuss in a further section of this video series.